I'm going to go a little quicker probably on this one because I did a pretty extensive job on day 4. But again, there's an infinite amount of ways of naming point P. Not of plotting it, like it is right here. Why is it there? Well, if we go in the negative direction here, that's negative 5 pi over 6. Well, this is the rotated axis right there. So when we start in standard position and rotate it this way, when we have a negative r, we have to go 4 in the opposite side. Okay, so that is point P. There's just a lot of ways of naming it. This is a way of naming it such that r is negative and theta is between 0 and 2 pi. Well, I can get there by going in this direction all the way to 7 pi over 6, right? But then doing a negative 4. So we are giving you situations that you can, depending on which way you revolve and how many times you revolve, these answers all work. Now, this one's not possible. First of all, I want to point out the way that this is kind of written here is saying negative 5 pi is less than theta, which is less than negative, doesn't show up great there, but basically 5.5 pi. All right, I want you to think about this real quick, and it's just kind of annoying. I should have fixed it, but this is a smaller value. Like when you think about a number line, this is a smaller value than this. So technically, these should have switched places here. I mean, that would be an accurate way, or just switch each of these signs. But bottom line is, you might not even have caught that, but this one is not possible anyways. So I'm not saying not possible because I had that mistake. I'm saying not possible that even if we write it the correct way, if we say negative 5.5 pi is less than theta, which is less than negative 5 pi, that's the way it really should have written, because left to right inequalities. But think about this right now. If I go around negative, ready? I'm going to go around negative, and that would be, whoa, I don't know what that just did. All right, let's go blue. So if I go, I've gone negative 1 pi, negative 2 pi, negative 3 pi, negative 4 pi, negative 5, and negative 5.5. It's saying it should be up here in this quadrant. And since point P is here, the only thing we can change is have plus or minus 4. So it's impossible to get up there anyways. So simply I would just say that that's not possible. All right, so I hope that wasn't too confusing and that didn't mess you up too much. I do want to just point out here that the fastest way, I mean, look at me here. I want you to know I'm not struggling. I'm not struggling to find my answer here. If I give you an r and a theta, we have a formula. Follow it, learn it, get it down to a T. The formula is x equals r cosine theta. Well, theta is not unknown. Theta is negative 3 pi over 2. So my little diagram here is like, all right, here's negative 3 pi over 2. Well, what's cosine? Cosine is 0. So following my formula, r, negative 2, times 0 is 0. R times sine theta, well, sine is 1. So negative 2 times 1. Just look at those two little formulas. If I give you polar coordinates, you have two formulas that give you the x and give you the y. Okay, so again, I'm not going to go through B right now, but that's exactly what I'm doing. Get to the reference angle, follow your formulas, you should be good. All right, now this one is the different scenario where it's, all right, find the polar coordinates. Again, there's an infinite amount of answers. So as long as your answer matches up, we're good. I mean, look at this here. I'm doing this logically. I'm thinking, hey, 0, negative 4 root 3, that's literally going to be straight down here. So why don't I just think about going to 3 pi over 2? Well, the axis is rotated, right? The axis is rotated down this way. So I would have to have a positive 4 root 3 because that's the distance to the point. So when I use 3 pi over 2, I'd have to have a positive 4 root 3. If I wanted to use pi over 2, which would be totally fine, well, now I have to go opposite. So it'd be a negative 4 root 3 for my r value. So again, the positive negative r thing kind of throws people off, but think about the rotated axis. Like this one. This ordered pair is x, y. They're both negative. That point has to be in the third quadrant. We go left, we go down. So make sure when you get your answer at the end that it actually matches with this third quadrant. I might have just said fourth quadrant a second ago. I don't know. I don't remember. But left, down, third quadrant. Okay, so left 4, down, forward 3. I would love for you to recognize the 4, forward 3, 8 relationship, which is the 30, 60, 90, right? So if you didn't have that relationship, you can still do Pythagorean theorem and you could find out what your R value is. But, okay, so what is this reference angle? It's 60 degrees. But here's the kicker. What is this angle? Not the reference angle. What is the entire angle here? And that's 3 pi over 3 plus 1 more pi over 3, 4 pi over 3. And then we want a positive 8 because we're going along that. Or if we wanted to just go up to pi over 3, which would be fine, and then go negative 8, that would be okay as well. There's obviously more answers, but that's the idea. These two should be straightforward to you coming into the test. All right, this one here is somewhat similar to a problem we did on worksheet 4, just real quickly. When I go left 1, down 5, I can do Pythagorean theorem to get root 26. Just notice that our R value can be plus or minus root 26. But again, there's many different ways to write polar coordinates, but root 26, I used a positive value in my final answer here, and I'll show you why in a second. But the biggest thing missing here and why we're telling you to use a calculator is that we don't know this little reference angle right here. So if I make this little reference angle theta, tangent theta is equal to 5, or negative 5 over negative 1, right? So when I do that on the calculator, what do I get? I get 1.373, okay? Well, what does that mean? Well, again, technically, guys, when we're doing this, okay, technically when we're doing this, an inverse problem is restricted for tangent into first or fourth quadrant. Since it's positive, right, it's going to be this quadrant here, but you're just coming up with the reference angle. So know that this angle right here is 1.373. That's what the little angle is. Well, this angle is pi. So if we do pi plus 1.373, we actually get 4.515. So that is the angle all the way to here, and then we want to go along that axis, so that's why I used a positive 5.099 there. All right, let me see what I want to say about this one. I want to say that I'm going to make another video so it doesn't get too long.